So, let me start our seminar today. We have two great visitors with us, and I'm very happy that they agreed to come, Barbara Cross and Candy Seidner. I don't know, you all are too young to remember Barbara being here. I don't want to say that you are old, but to remember Barbara being here for Mathesius' lectures. But nevertheless, I'm really very happy that they both could come and give a talk here at this seminar. I don't know whether Barbara needs too much introduction. She is now at Harvard University. Actually, we met when you were not yet at Harvard, but you were at Stanford.
And I was still a PhD student.
Yeah. And her name, of course, is very well known, I would say, to all of us, because actually we have had many common points of interest, going back to her focusing PhD thesis and attention paper, the work together with Candy. So I think that we are really very close in the interests we have had, and I'm very much looking forward to her talk. Thank you very much.
Thank you, Eva, very, very much. Actually, I misspoke. I had finished my thesis when I first met Eva in person, but I met her work when I was doing my dissertation, and you'll see that it played an important role. So it's wonderful for me to be back after a few decades. So I think many of you weren't even born when I last was in Prague. And it's delightful to see how the computational linguistics group has grown here and how Prague has changed. But for me, Professor Hajtova remains a model in her research and in her interactions with students and people around the world. So really, it's an honor to be here. And I understand this is part of the FJelinek seminar series. And in my mind, Prague had a very important influence on Jelinek, which is after he got to know people here, he started to realize that maybe linguistic theory was worthwhile. and this is important today because he thought all you needed was statistics before. So I think that lesson remains. Feel free to ask me questions as I go. If you can't hear me or I'm talking too fast, just wave a lot. Okay.
It's a kind of mystery, or not really mystery, but the microphones are just for
recording.
And not for all of us. So you don't rely on the voice.
Can you hear me? Can you hear me in the back? Yeah, I frequently. Yeah. But thank you for. I had this very interesting experience a few weeks ago. About a month ago, I introduced a speaker somewhere else with this same setup, and I didn't have anything for recording me. So the videotape of my introduction, I look like I'm just gesturing, and it's really amusing. And then in the question answer period, they also didn't get the questions, just her answers. So I guess I'll try to repeat questions also so that they get recorded. Okay, so many of you, I hope all of you, know about Alan Turing and his imitation game and his conjectures about that. The paper that he wrote on that, as this slide says, was written in 1950 when the world was very, very different in many ways. His conjectures about the imitation game, or the so-called Turing test, have proved not to be true. But this conjecture that I have on this slide, that people, by the turn of the century, or in this case the millennium, would have spoken of machines as thinking without ever being contradicted. That turned out to be true. Even 18 years ago, people would say, why does it do that? Why does it think that? And nobody would contradict them. But many people, at least many of the people I know, after a while say, well, why did it do that? It seems so stupid. I thought it was smart. And a big role in that area is the way in which computer systems speak and interact with us in natural language. Oops, I'm going to learn which one. So I want to look a little bit at why that's the case and what computer systems now, what the chatbots and the phone, how many of you have smartphones that you talk to? Or try to talk with? Not with, but to, yeah. So why are they so disabled? After decades of our being able to tell people from theory how dialogue works, why are these so limp? And I'm going to use this example to motivate some of the discussion, but I'll come to more serious examples later. So this is an example about something that happened for me just before I taught a class. I teach a class now on intelligent systems design and ethical challenges. And I wanted to talk about phone personal assistants, and so I tried a few examples. By the way, one of the things that's great about learning linguistic theory is that you can break any of these systems in about 3 queries. They should hire us all to be the quality assurance people. Okay, so this is what I asked the system: where's the nearest gas station? And it gave me a list of 16, and then I asked which ones are open, and this is what it said to me. So this is surely not what I meant. Just see what happens here. Yeah, okay. I've just learned something very interesting about this. Where's the technical person? It advances here, but it doesn't advance on my laptop. It's okay. I think I can point without it. You know what? Let me just do it from the laptop.
Okay.
Technology. I'll use this. I'll just advance from here. Well, maybe I won't advance from here. There we go. No? Wow. It was working before from here, before I put this on.
Okay, so let's try opening the presentation one more time.
Sorry. I think that keyboard thing might have messed things up.
So yeah, so it looks like it's in
No, now we're good. No, we're good.
Okay.
Okay. We're mostly good. So what I said about this and what a claim that I made is that if you look at the errors that computer systems make, especially with language, but more generally, you can see how they work and therefore what might not be right with them. And so I want to just bridge from that. So why did it do this? Would you like me to search the web? It didn't say, I don't know. It had no sense of discourse and how dialogue and how it works. So I'm going to start from that, and I'm going to talk first in this talk about the foundations of discourse and what we have known since Professor Heicheva and I met in the 1980s. And then I'm going to extract from that some dialogue principles for design of systems. And I want to do that because much of the work in computational linguistics and natural language processing now is based on various kinds of statistical methods, neural models, and so on. So the question is, given that these theories were developed in a more logically oriented and theoretically oriented world of language processing, do they have something to say to those? And I'm going to argue that they do. And then I'm going to end with some scientific and ethical challenges. And you'll see the reasons for the ethical challenges as I go along. So I want to talk first about getting from the models we have and the theories we have to systems. And I want to begin by noting that this is when I started. in the 1970s, the ways in which speech systems and computational linguistics were organized were very much around different functions and different language functions. So acoustic phonetics, syntax and parsing, the lexicon, and the dialogue challenges we considered were related to prosody, reference, therefore focus and topic came up, and to language as action. Now, if you look at the discourse and dialogue literature now, people talk about things like entrainment, emotion detection, how can you match the people that you're talking to, deception detection, and the dialogue systems, the chatbots, are focused on things like turn-taking, clarification, and negotiation. So a very different way to divide up the language world, and the applications are very different. So in the 70s, we were very concerned with, could you ask questions of a database and get answers out? That actually turned out to be not a great application area because, as you'll see, or you may remember, one of the things that Candy and I argued was that you couldn't understand dialogue if you didn't understand the purposes that people brought to the dialogue. And people bring many different purposes to asking questions of databases, and we didn't have those. The application focus now is basically filling out templates where you do have the purposes, you do have the reasons, so you're going on a trip or you're making a hotel reservation, but it's a very narrow purpose. And chats have, as far as I can tell, no purpose at all. So we'll come back to those. So very, very different situation. So just a brief look. I'm going to give a summary of the kinds of findings we had then, and then give you some examples of the theory in action. And the primary technical advances that we made at this time were to argue, and you'll see this, and show that dialogues had structure. So they weren't a sentence after a sentence after a sentence. But just like sentences have structure, dialogues also had structure. That reasoning about that structure required thinking about prosody and purpose, and a different kind of plan from the single agent robot plans that were common then. And that actually you needed to collect real data in order to understand how people spoke. So I did what became known as Wizard of Oz experiments. That is, I put two people in two different rooms. I told one of the people was a confederate of mine, knew what the experiment was. The other was somebody who thought he or she was speaking to a computer system. And we collected dialogues, and I'll give you an example of that, and then looked at that real language behavior. What I say now to people who are working on dialogue is that Twitter is not real dialogue. And if you want to build a system to have a dialogue with a person about something they're trying to get done, basing your learning on Twitter is highly problematic, and we see this in the systems that are out there. We also learned, and I think that the Prague School has been very active here, that prosody isn't something you just layer on afterwards. It's a big part of language from the beginning. And intentional structure is key to understanding. So that's kind of the language lessons, the dialogue lessons. I also had a few career lessons at this point of my career. Before I finished my thesis, my colleague Jane Robinson, who is the person who introduced Professor Heichev and me, invited Noam Chomsky to have lunch with the whole group of us who were working at SRI on speech understanding. And I was very shy then, really shy. I hid under the table, essentially. I mean, nobody believes this now, but I'm still shy, but I figured out how to fake it. Okay, so I didn't say anything at lunch. And toward the end, Jane turned to me and she said, "Barbara, you have to tell Noam what you're working on for your thesis." And I, in my most timid voice, explained what I'm going to tell you about. And he said to me, "Very interesting, but it's impossible to formalize dialogue." So you can imagine how happy I was when I met you, Eva, that there was some other person in the world nutty enough to think you could formalize what happens in discourse and dialogue. A little later, I had an argument with John McCarthy, so one of the forefathers of artificial intelligence, who was arguing that you didn't need to think about how people thought or their cognitive processing to build intelligent systems, because after all, birds didn't flap their wings. So I tried to convince them that to understand language, you would have to understand something about people and their cognition. I failed, although maybe 30 years later he came to believe this, 20 years later. So here's my lesson for those of you who are just students. Don't pay too much attention to those of us with gray hair if we tell you something's impossible. Well, Professor Heicheva, she doesn't have gray hair, so you should pay attention to her. Okay, but not to me. All right, so here's an example of the dialogues that we collected in those first experiments. There was an expert, that's B in this case, telling somebody new, A, how to do something. And what's interesting here is what's in bold. So I'm not going to tell you the whole dialogue, but notice that the person says remove 2 small set screws and then pull it off, referring to the flywheel. And then we see that the 2 set screws are loose, and then we get down here to this expression, loosen the screw in the center. But the last screws that have been mentioned, and that's true even with all of this other dialogue, the last screws that have been mentioned are the 2 set screws. And you can't have something in the center of 2 things. So what's going on here, and it's actually, there's more than this, there's a whole bunch of dialogue here, is that once you finish the task of getting the 2 screws off, you're done with the screws, and now the focus of attention has shifted to the wheel puller, and that tool actually has a screw in the center. It's like a corkscrew, except it's for pulling off wheels instead of pulling out corks. So if you know what a wheel puller is, you don't have any trouble with this dialogue. If you don't, it's a little weird. But here's an example where nobody has had any trouble with the dialogues, and yet it's very odd. So the dialogue starts with the experts telling the apprentice to assemble the air compressor, and if they actually get the air compressor put together, then depending on the particular dialogue, the expert ends by saying plug it in or see if it works. There is no intervening mention explicitly in the language of the air compressor. And yet none of the apprentices had any trouble knowing what it was to be plugged in, and people reading this don't have it. And this was in a room full of equipment that could be plugged in or not plugged in. And it was a long time ago. Computers crashed all the time, so lots of things could have worked. So essentially what this made very clear is what I said before. Dialogue isn't a linear sequence. I'll come back to intonation in a minute. And it's also, dialogue is not just adjacency pairs. It's not just questions and answers. And that's one of the things that I think is problematic in the systems being built today. There's an assumption that you can build a dialogue out of just a question and an answer and another question and another answer. So it's not, I always love this example from Livia Polanyi and Remco Schra, because it's not at all task-oriented. So in English, I'm not going to try with Czech. In English, and in any schools that still teach grammar, tell you that a pronoun refers to the last thing that was mentioned in number and gender. So if you read this, you can see that the last thing mentioned that matches the number and gender of them is kids. And yet, even reading it, most people figure out that it's not the kids that get put away, but the groceries. And if you would hear the recording of this, it goes something like this. John came by and left the groceries. Stop that, you kids! And I put them away after he left. So absolutely no question that there's an embedding. So here's the tripartite model of discourse that we developed. I've already said that the discourse is not linear, but chunks. Those chunks, what the chunks are determined by the intentional structure. That is the purposes for these discourse segments. So I'm giving you instructions in how to remove something. I'm giving you instructions in how to use a tool. I'm telling you how to cook the appetizer for dinner or how to get from here to Paris. What is it I'm trying to do? And the relationships between those purposes, and we'll see an example in a minute, tell you not only these embeddings, but also how the focus of attention shifts from the one purpose to another. So out of this work, we actually developed, what I've just shown you is really the global level of discourse structure, where you have these focus spaces that stack and pop, that hold in them the most salient elements to be talked about, and we use that to determine how noun phrases refer. There's also within the discourse structure, and this is most related to work that's been done here, so these are the focus spaces stacking, but within each segment and within each focus space, there's a more local level of attention going on, which Candy Seidner and I called immediate focus. In a very related work, Joshi and Weinstein called it centering, and so let me just say a little bit more about that. They were really interested in how you would integrate the meaning of one sentence into a whole discourse meaning. And so how you would constrain the number of inferences that a system needed to draw. So they were focused on that reasoning. Candy, in her work for her thesis, and later in the work we did on the tripartite model, was, no pun intended, focused on how you would interpret anaphors. And of course, those two things connect. And so later, Joshi, Weinstein, and I merged these things together and talked about centering as a process. And we called it centering in part out of respect for the Prague School and realizing that topic and focus had been used in other ways, and we wanted to be able to connect those to this. So I'm not going to have time to go into this at all, but it's a really tight connection to work that's gone on here. And I did want to point out there's really been interesting work recently by Andy Keller and one of his students, Rodi, on actually integrating centering with coherence relations. So if you're interested, that's work to look at. I have almost no time to go in detail into prosody, but I just want to point out how important it is to actually being able to detect how the structure changes. And I always want to start with this very simple example that even a single word can change the discourse structure. So, and my favorite word for that is incidentally. So if I tell you, maybe I should change it, that incidentally Ava walks 10 miles every day. I guess I should say 16 kilometers every day or something like that. You would hardly think it was accidental that she did that much walking, right? So the incidentally is actually saying I'm interrupting myself to tell you something else. But the interruptions can be of larger chunks of discourse and in different ways. Julia, there are many kinds of results on prosody, but this is, again, at a larger level. Julia Hirschberg and Diane Littman looked at a number of these so-called cue phrases, individual words or short phrases that would shift the discourse, and whether they shifted it or not, or the way they shifted it, depends on prosody. So I'm going to give you a minute to read this particular stream. This is from a radio talk show. And then I'm going to ask you about this word that's in bold here, and what it means. So let me give you a minute to look. Is everybody ready to vote on the meaning of that word? Yeah? Okay, so it could be deictic. That is, it could be referring to a certain point in time and essentially saying that the taxes have to be paid at this point in time. Or it could be interrupting the discourse. So there's a three-way vote. Just from looking at that, are you 100% sure it's about time, 100% sure it's about moving the discourse, or not sure? Okay? How many people think it's about time? How many people think it's about the discourse? How many people aren't sure? Now, if I say, so in other words, I'll have to pay the full amount of the tax. Now, what about Pennsylvania's state tax? How many people think it's shifting the discourse? Okay, so the now makes it completely unambiguous. We also looked, Julia and I then subsequently did work on looking at how the larger chunks, the beginnings of discourse segments and the ends are indicated, and we found a number of markers. And then with Christine Nakatani, we looked at accent placement and other prosody that's telling you how the discourse structure has changed. So robust information that discourses chunk, that the chunk is signaled by the language, by the syntax, by topic focus, by intonation, and that those chunks affect how you interpret the meaning of different utterances. So that's the linguistic structure, the chunking, and the focus of attention changing and its influence on language. And then I just want to say a bit about the intentional structure, the discourse segment purposes, because this was the beginning of my segue from being, I'm going to use the word focus all the time now, focused on language and dialogue to looking at collaboration. And the work that Candy and I did had roots back in the philosophical work on language as action, which then various people in AI picked up on, including Chip Bruce and Ray Perro and James Allen and Phil Cohen, who were his students, to use how many of you have taken a course that covers planning in artificial intelligence? Anybody? How many of you have taken an AI course? Okay, so I just explain a little background. So in the area of artificial intelligence, in the 70s and most of the 80s, people were focused on how an individual robot could put together a plan of action that would get itself or the world from one state into another state. So how it could get from the state of no dinner to the state of having dinner. They never thought about cooking dinner, but that's better than the blocks they thought about stacking, which were kind of boring. So it was all focused on how you could model actions and reason about putting them together, assuming there was an agent that had accurate information about the world. And then people interested in language as planned behavior looked at the reverse of that. Could you take information about planning and plans and how they fit together and infer a bigger purpose from a stated purpose? This is a dialogue from really the first work that looked at this idea of detecting intentions by thinking about plans. And what you see going on here is that C is trying to get B to take care of the bugs on plants and not quite succeeding. You know, rhubarb has holes. So what? It's covered with little bugs. Who's we, should do something about it. What Candy and I realized looking at all of this work on intentions and utterances was that it wasn't sufficient for discourse, that you couldn't build the plans needed for discourse or reason about the intentions needed for discourse from these single agent plans, because in dialogue and discourses of any sort, but let me focus on dialogue, you have at least two participants and they have different knowledge and they're interactively doing something. So it's not like I have a plan to do this and you have a plan to do that and our plans just happen to match up. There's an interactive building of plans. This is actually an aside, which I won't go into, but in any detail, which is subsequently, in fact, very recently, it's become clear that the human language capacity and intelligence as a whole is oriented in social interaction. So long before we are able even to fully communicate, infants' language development depends on social interaction. And there's also very interesting work on infants that shows if they don't have social interaction, their brains throughout life are smaller and generate less energy. It's actually quite scary to think about that. Okay, so I said this, that we argued that intentional structure couldn't be represented by single agent plans, and then there was a whole development of what we called shared plans, and I'll actually show you what that is in a minute. That is designing the plans of multiple agents, where instead of just thinking about the actions and how they fit, you think about the beliefs of the different participants and the ways in which those actions fit together. So I'll pause here for my second career lesson for those of you who are still working on your dissertations and starting your own research. When Candy and I first argued that the individual plans of individual robots were not going to be sufficient for dialogue, our colleagues, all of whom were taller than me, I have to say, they all patted me on the head, basically. Actually, one really patted me on the head and said if I just thought harder, I would be able to figure out how to do it that way. So, being a little stubborn and persistent pays off. Eventually, I came up with a Block's World example that convinced them, and several of those people also then developed their own teamwork theories. So if you tell people an idea you have and they tell you, well, that's too complicated, find something simpler, maybe you're right and you should persist. And after all, we persisted on dialogue for a while and people began to pay attention to us. Okay, so let me give you a snippet of what shared plans looks like. And this was initially when Candy and I developed it was the plans of two agents. Then a colleague of mine, Joyce Friedman, actually I think you knew her, said, look, you studied mathematics. What's special about 2? Do n. Well, it turns out n is a lot harder than 2, and it took a long time, and Sarit Krauss joined in this. So I'm going to show you in English what was actually done formally in a logic. But the English gives you the basic principles. And what it's important to understand is if any one of these principles doesn't hold, teamwork will fall apart. I mean, you might be lucky and it doesn't, but it could fall apart. So the specification, if you study computer science, there's a notion of a program specification. This specification has commitments, which you can think of as being represented by intentions, and it also has mutual beliefs or consensus, which is decision-making to get to an agreement and to get shared beliefs about how the world is. So we need the team members to commit to the performance of what's going on. We need them to agree on how they're going to do the work. That's we call this a recipe. What are the steps that we're going to take? And on who's going to do what. And there's something very important about the recipe, which is maybe you don't know everything you're going to do, but you develop the start and then you elaborate it as you see how your plan is working. If you run into trouble, you may back up and do something else. And on the who's going to do what, based on the way this is represented by intentions, there's the presumption, actually the requirement, that you assign to an agent only things that it can do, only tasks that it can do. So I can't be assigned the task of cleaning the ceiling without a ladder because there's no way I could do that. It's a beautiful ceiling, by the way. Okay. This will come back to haunt us, okay? And then there's the commitment to tasks and to each other's success. And this gives you delegation, and one of the important things about delegation is that when you agree to take on a task and I'm not doing it, I have to trust you to figure out how to do it, and also to let me know if you run into trouble. And if you run into trouble, I have to be committed to helping you out of trouble. Okay, so if you think about this as the basic structure for handling dialogue and the intentional structure of dialogue, each of these components can lead to a different discourse purpose, and that can lead to the structuring of the discourse. So essentially what happens is you can ignore anything other than the FSPs here. You can see if you have a plan, so a shared plan to do some big thing, that dominates a shared plan that is bigger than the shared plan to do a sub-step, then you're going to have this kind of structuring of the discourse where the thing that dominates is an outer discourse to the thing that's inside. And my student Karen Lochbaum used that to explain, and I'll just show you with this example, the embeddings of dialogue based on focus spaces, so based on shared plan structure. So here's this little piece of dialogue that we saw before, and what you see going on here is that the apprentice is missing recipe knowledge about how to do something, so that generates a sub-dialogue. And then when that's finished, the apprentice here is missing a piece of information that would make her capable of doing an action, which is identifying a screw. So that gives you another sub-dialogue. And I don't intend for you to see anything other than the bold in the relationship of these focus spaces. But this is essentially how you would get the embeddings of purposes that would lead to the embeddings of focus spaces for the first part, the recipe part, and then for the second part. Okay, so that's a very brief tour of the intentional structure. And now I'm going to digress because I want to get to what principles we could take from this and use for dialogue. And the digression is going to be on work that I've done using this shared plans in healthcare. So it's really a pretty big digression. One of the things that I argued early on is that teamwork isn't, this is from the work Candy and I did, it isn't simply the sum of individual plans. And another thing I argued is you have to, because I'm going to come back to this, you have to design collaboration in from the start. So we saw that. So this is the theory. And so one of the things to recognize is there's many different ways to use the theory. You can use it to specify pieces of a system and how they should work, and we've used that for interruption management. So you don't want to interrupt somebody and make them unable to do what they're doing. Not going to talk about that today. You can use them as a design guide or, and I'm going to really focus my attention here, as an analytic framework. So when thinking about the design guide, the way in which we've used the theory for as a design guide has been mostly in the educational sphere. So I'll just give you a hint of how that works. And in particular, we've used it in two ways. One is to decide what the system will do as opposed to what a teacher will do. So over the years in the United States, people have suggested we don't need teachers, we can replace them with computers. It's not true. But we can augment what teachers are capable of doing. So a classroom, one of the things that we know about learning is that you learn better if you do things. And there's a whole set of software available now for teaching people, especially science, but it's also moving into the humanities and the social sciences if they can experiment on computer systems with various programs. But a teacher, even with 15 or 20 people, can't follow what they're all doing. A computer system can. So the idea of the systems we've built is we assign to the computer systems essentially watching what the students are doing, separating out the actions on the path to a solution from the actions that are either errors or just playing around with the system. And to the teacher, using that information about what students are doing to actually figure out who needs help and go help that group of students. And we've done this in two settings. The first setting in which we did it was teaching middle school students statistics. And that led to new algorithms for recognizing plans because the kids didn't always, they would play around a lot, let's just say that. Subsequently, the postdoc working on this, Kobe Gall, became a faculty member, and he did a project with somebody at Carnegie Mellon who had a program. This is a virtual chemistry lab. There are beakers and you pour things back and forth. It was the same idea. It's a more complicated situation for recognizing plans because you have liquids that are continuous. I use this example because I heard the chemist who developed virtual labs talking about how he used the system. And he said for him, the most compelling thing about the AI system telling him what the students were doing was that he thought he knew how his students were solving chemistry problems, but when he looked at what the system told him, he realized he had no idea how they were doing it. And so he really changed his teaching for that. Kobe and some of his students are now using this general idea of what the teacher does and what the system does in teaching geometry. And here he's actually using deep learning techniques on chats that the students have about what they're doing to let the teacher know when the students have stopped talking about what they're supposed to be working on and started talking about something else. What's also interesting about this is they've actually used it in a classroom. The other systems were used offline just to tell teachers and see how they used it. This is actually used live in the classroom. Okay, so that's, again, the design idea. Take from the shared plan specification, you have to support other people in their work so you don't interrupt when it's not appropriate, and you can only be assigned tasks that you know how to do. Okay, so I want to shift then to the third use, which is as an analytic lens. And this we've been doing in work that I'm doing with a pediatrician at Stanford. His patient base are children that have what are called complex conditions. That is, they have 3 or 4 or more different body systems that aren't working right. It could be that they were born with some genetic problem. It could be they were in an accident. There are a whole bunch of reasons. Leaving aside the autistic spectrum, there are very few children who have any one disease and thousands of these conditions. So unlike in the case of adult complex conditions, which are essentially diabetes and heart disease, you can't just do data mining on big databases. But we could help in this setting because the child is developing over time, so his situation changes, and remember, shared plans lets that happen. And there are many, many people, and I've just put up some of the people. It's not only one doctor and the parents, but also teachers and health. They can see up to 10 to 15 different people providing care. And I used to take votes, but it got boring. Nobody can follow what 15 other people are doing. It's just not possible. So I actually love this picture. I did not make this picture, but it shows this shows a patient, but you can think of the parent and the primary care doctor, and all of these people are sending them information, and just sorting out what's important and who's related to what is a very difficult thing to do. So what we realized, the first thing we did, just like the first thing I did with the air compressor, was to study how people communicate. The first thing we did in this setting, and this is work that my student Ofra Amir did, was to interview parents and providers to understand how they worked and how their plans worked. And we recognized that the plans here are very different from the plans that AI had looked at before. That first of all, there's no hierarchy to the team. Nobody tells anybody else what to do, so you don't have instructions coming down from the top. The plans are loosely coupled, so any one physician only knows a little bit about what anybody else is doing, mostly from their specialty, and various other things, which I won't have time to go into. So we realized that we couldn't use plan recognition anymore to figure out who needed to know what when. So most of the work on knowing when to interrupt and knowing who to share information with is based on information theory and computing the value of information. But to compute the value of information when you don't have detailed plans is not possible. And so we developed an approach that uses interaction among people to decide who needs to know what. And then when we thought about how to embed that in a system for physicians and particularly on parents, we went back to the shared plans specification. And okay, so this is where the design principles begin to come in. So they have to reach consensus on the recipe, and we realized we could build a tool that would help them reach that consensus and remember and be able to pull out when parents went to a physician what the plans were, and would allow them to change. So there is in healthcare a notion that you should have healthcare plans. Initially, they were made on paper and stuck in a drawer. Now they're made on a computer and nobody ever looks at them. It's kind of appalling, but no, the systems don't support looking at them. and that we could support communication and coordination. And as I said, we could develop this algorithm for information sharing. Okay, so that's what we did in that setting, and we can take the same idea and look at how we can use the tripartite theory of discourse structure and shared plans to understand dialogue structure more generally. And so one of the things we see is that there's this decision-making activity. And so you can get structuring out of the goals of the dialogue or the purposes of the dialogue, out of when you're reaching consensus on how you're doing what, or out of when you're reaching consensus on who's doing what. So all elements of a dialogue and its structuring that you could use, even if you're doing deep learning. It doesn't have to be that you're doing syntactic parsing and semantics and so on. And likewise, you can see structure being spawned that you could use in chatbots and personal assistants based on commitments that people are making. So when you're making a commitment, where is that commitment coming from, and so on. So those are some of the ways you could take these principles to dialogue. Okay, so that's a sketch of getting from the theory to the principles. And now I want to turn from this to a different topic, but it's related, which is ethics. And remember I said you can't commit to doing what you don't know how to do. A big problem with the phone system I showed you is that it committed to the how many gas stations are there and so on, where are the gas stations, is that it pretends to have capabilities it doesn't have. So it's kind of amusing in the gas station, I can deal with it. But here's an example where, and I'll show you another one that doesn't have to do with children, where the fact that a system pretends to have a capability that it doesn't really have is dangerous. So about 2.5 years ago, there was a cover, this is the New York Times Magazine. The cover of it was the Barbie doll. Any of you know about Barbie dolls? Yeah? So they used to be that they were bad for girls because they had this ridiculous skinny body. Like they had a waist, like my waist would be this big if I were a Barbie doll. Okay, so this is what I'm going to show you is the emotional equivalent of the Barbie doll having a figure that's not good for little girls to see. Okay, so this was a new doll which was going to speak to your child and, quote, become your child's best friend. It was designed for 3 to 8-year-old children. I'll show you a dialogue. So this is actually from the New York Times Magazine piece. So they probably fixed this particular example, but there are other things that are even worse. Okay. So the Barbie doll learns that this kid has a sister and asks what's something nice that your sister does for you, and the kid says nothing. And the Barbie doll says, well, what's the last nice thing your sister did? Remember what I said about errors? So we already know that this Barbie doesn't understand the word nothing and is just kind of plowing ahead with some script. Actually, the way it works is it has a script. You can go online, 300 pages, you can find the whole script. Adults don't follow a script. We already see this with all the chatbots out there. I can tell you, I have never met a 4-year-old who would follow a script for very long. Okay, so the kid tries to be a little bit cooperative and says, well, she helped me, but then she destroyed it. The Barbie doll has no idea what the word destroyed means and says, oh, tell me more. Okay, they go on for a while, and then the Barbie doll, right, completely clueless, says, have you told your sister how cool she is? She says she's not cool. That little word not again. She might appreciate hearing it. Okay. So, I know, it's so bad that you want to laugh. But think about this. This is a child at a stage where you're trying to teach them about how to have conversations with people and what it means to have a relationship. And this doll is essentially teaching the kid to pay no attention whatsoever to what people are saying to it. It's hardly a model for friendship. There are many other issues which I won't be able to go into. This doll could have at some point instead of just following the script and saying, well, I don't understand, but I'll just do the next thing in the script I have, it could have said, I'm just a toy and I don't understand you. Okay. There were different but related problems with Microsoft's Tabot, which was, I don't know if you read about this here, but this was the chatbot that some people at Microsoft released that, as it was caricatured, went from, a friend you could chat with to a Nazi in 15 minutes. It was it was really racist. It was horrible. Okay. So there's something wrong here with our people in the field releasing these things that raise ethical concerns. So I think the great thing about artificial intelligence and natural language processing work at present is it's actually out there in the world. So when I was finishing my thesis, I remember taking a walk with a fellow graduate student, and he said to me, it's good we don't care about making money because AI will never amount to anything. Okay, I decided subsequently I would never make any predictions about AI. But now AI is out in the world, and we have a responsibility to actually take what we know about language and make sure that the products that are out there aren't doing things that could cause harm. So remember that I said dialogues are structured and not linear sequences. You can actually see from just these characteristics of dialogue, why it is that open domains like social chatbots and the Tabot are harder to manage than closed domains like travel assistance. Because in travel assistance, you actually have the intentional structure. You can begin to build around it. And you can also see why short dialogues are easier than longer ones, because you don't have to go very far. So a question-answer pair, well, an adjacency theory will do. The problem is that this isn't really how we interact with each other when we're doing any real work. And so anytime you build a system that is a closed domain in a short dialogue, you're pushing people to behave differently from their natural language behavior. And that can be a problem. So I showed you this example before. Here's a more problematic set of examples that's exactly this kind of thing. It would be interesting to try this in Czech, by the way, with your smartphone. So in English, in the United States, if you ask your smartphone, my students found this, by the way, where the nearest emergency room is, you will get a hospital with an emergency room. If you ask it where you can get a flu shot, okay, so normally if you asked a person where the emergency room was and they could tell you that, you might later ask them where you could get a flu shot and assume they could answer. It gives a nonsense answer. I've never been able to figure out why or what. These are some of the answers that have come back. And it's not that it doesn't get the speech right. It actually says, where can I get a flu shot? I cannot figure out what's wrong. Okay, but here's the one that really bothers me. If I ask where I can go to get a sprained ankle treated, just like in the gas station case, it does a really wrong thing. It gives me a set of web pages that tells me how to treat a sprained ankle. So, okay, that's bad enough for a sprained ankle, but suppose it were a heart attack or something that seemed like a stroke. You could actually cause a death by not getting this right. So I am now on a new soapbox. Instead of my soapbox my soapbox is about collaboration being designed in from the start and dialogue not being just sequences. I think it's really important that we design ethics into any system from the start. If we're going to put AI out in the world, because we're building systems that seem intelligent in ways that will lead people to generalize from how we generalize appropriately about each other. And we can do that either by designing the system with ethical principles in mind. That's the very least that we could do, and we can do it with any systems we build now. Or we could start thinking about how to have systems reason ethically. And there are people doing this. I just think that's a really hard problem. It's hard enough to get common sense reasoning right. This has that same problem layered on top of you have to have agree on what your values are to do that. So the main thing I want is to get people to design with ethics in mind from the start. And I'll tell you a story that led me to this, and also led me to the importance of educating computer scientists. So I said I have this course on intelligent systems design and ethical challenges. At Harvard, we typically let however many students want to take a course take it in computer science. Some other fields don't. But this course was restricted in enrollment because it's meant to be highly interactive and students do activities in the class. So I restrict it to 24 students. This past year, 140 students sent in essays applying for the class. So it's not like they just said they wanted it and we picked numbers. So really, they were really serious about it, and we picked people who were clearly serious about it. That's all background to the story I'm going to tell, which is that one of the things that I talk about is recommender systems. So Amazon recommends products, certain websites recommend news stories, unfortunately. Netflix recommends movies. What's the underlying technology to how those systems work? So that's a section of the course. And in all of the sections of the course, we start out with an ethical challenge that's in the real world or in science fiction. We also use science fiction. They actually read about the Golem of Prague as a first intelligent artifact. And so for this section, they read about an emotion contagion experiment that Facebook did. So about 3 years ago, for a 2-week period, Facebook, for some users, increased the number of positive stories they heard, or decreased the number of negative stories. I don't remember. So they got a different news feed, and they wanted to see whether that percolated through friends. They did not tell the users they were doing that because they're a company, and so they were just testing different interfaces. By the way, if you'd done that experiment in a university, you would have had to do what's called an institutional review board. You would have had to ask for permission to do this, and you would have had to show there were no ill effects or say what you were going to do about it. They didn't have to do any of that because they don't get government money. They're just, okay. Just to know, we're all guinea pigs for all of these things, these systems. Okay, so we spent an hour and a half on Tuesday talking about the ethics of that experiment and what you should do, and if you were at a company, because too many of our students go to companies, if you were at a company, what you should do. 48 hours later, in the next class, I taught them the guts of how these systems work, and the in-class activity was for them to design a part of a system for a social networking company related to exercise clothing. They had to tell us, they had to design the technical part, and they also had to list the characteristics of the users they were going to collect. And then in class, I wrote down all of the techniques they were going to use and all of the characteristics. And as I'm writing down this list of characteristics, I'm thinking, gosh, 48 hours ago, we talked about ethics. This is a really interesting set. So I said to the class, so I'm just curious, how many of you in your groups, because they did this in 3 or 4 person groups, while you were figuring out which characteristics you would collect, how many of you talked about ethics? Okay, none. The first 2 times I taught the course, none, 0. Now these are students who care about ethics. 48 hours earlier, they'd had intense discussion about ethics, and yet there were none. I will say, this year when I taught the course with a lecturer from philosophy, 3 groups out of 8 did talk about it. So we're making some progress. Okay, so I asked on the assignment. The first time I had to run back and change the assignment before I gave it out. But I asked them, why didn't you do it? And they said, well, in essence, the answer was, well, it wasn't part of what we were asked to do. We know we have to write efficient code. We know we're supposed to make money, but you didn't tell us we were supposed to be ethical. Now, by the way, I think all of you would have done the same thing. So just want to say that. This is not about Harvard students. These particular students care a lot about ethics. I mean, you can see this throughout the course. It's that it's not present in front of you. So that's my soapbox. We have to educate computer scientists about the challenge and include ethics in product design. And I even said this when I gave a Microsoft Faculty Summit talk, and they didn't boo me out of the room. So I will say at Harvard now we are experimenting with having an ethics component in every computer science course that we teach. A mini 1 or 2 lectures, and I just hope that I'm trying to spread the word. And you have a philosophy department here. The way we can do it at Harvard is we have philosophy PhD students teaching the ethics because they know something about this, whereas most of my colleagues have never studied ethics, unfortunately. Okay, so that's my soapbox. Let me go back to challenges. Here are some, so that's the ethics challenge, but there are many scientific challenges now for dialogue, and I'm hoping that some people will take these on. So I've talked about integrating principles of dialogue foundations with data-driven techniques. I think that's one of the most important things to be doing now. And it's not just our models, but also models developed elsewhere. How can we get around, so you don't, if you're not hand coding, that's fine. You don't have to get a lot into the models that way. But even if you're running machine learning, you have to make sure the data you're running on is broad enough. And here there are questions, we have different cultures, we have different languages. I always thought, Eva, that if Noam Chomsky had grown up talking Czech, he would have come up with a very different formal theory of language than he did with speaking English, let alone some other of the languages that are around. And also, something that's very much on my mind, if you look at systems out in the world, they have very little of what the research frontier in natural language processing is. So how can we do better about that? And with this, I will just say lots of people have contributed to this. I have lots of people who have inspired me. And then my last plea to the students. So this is something that Albert Einstein said, which I really love. Formulating the problem is more essential than solving it. This is where creative imagination and progress will come from. So as you choose your problems to work on, choose the hard problems out there. Don't just choose something where you can, increase the accuracy by 1%. We really need challenges that are out there in the world. So thank you.
Thank you very much. I think we can more than agree with the last but one slide that challenges are important. I mean, I meant this one. And we have another quotation, I think, which we like, my discourse people, that you never know whether you are right or not, that you always may make some mistake. Let me open the floor for, I think we have 10 minutes for discussion. So please use those 10 minutes.
On any aspect of what I talked about. And I'll just say in response to what you said, Eva, that if you don't make mistakes and get some things wrong, you're not taking enough risk. I think this is really true.
Okay, my question, I am actually very new to this theory, but it seems to me that your theory of the focus spaces and the structures of a dialogue could have implications, for example, for machine translation. Currently, all the engines I know about treat sentences as isolated things. Because treating higher structures is too much of a computational complex task. But maybe this approach of structured parts of the text could bring some light to this area as well.
Yeah.
So what's your thought about this?
Yeah, thank you for that question. And I hadn't thought about machine translation in this light so much in general because it's often driven off of text. But I think absolutely if it's dialogue, but I also think you're right that if it's text, that this could be of benefit. And I think machine translation is another area where we read a lot about the successes, but not about where it fails. And it's again an issue where if you don't have a lot of data in the particular area, those techniques don't work. And if there's anything at all subtle in the translation, you can also break those systems. So it could be very interesting to look at this kind of structuring either in a text or in a dialogue, and then try to do so everybody thinks Google Translate is great, but I can tell you I've given it 3 sentences in a row and it makes a mess, and I'm sure that you've had this experience. So it would be very interesting, I think, to look at where it's missing some properties of dialogue and discourse, from topic focus to these larger structures. I think it's a great idea.
Yeah. So I will have one intermediate question before people may think of some more. At the beginning, you said that the progress, or what I can call it the progress, goes from database queries to template filling. And I thought, when you said that, I thought I understood well. But then, when you spoke about open domains, do you think that this template filling is possible to be designed for open domains?
No, very, very good that you picked up on 2 different slides that don't really connect. So that first slide, what I was saying is here, the focus of what we were trying to get to work was databases. And now and I should have said this, with the systems that are out there commercially, it's all template filling or these chatbots. And the template filling is closed domains, and the chatbots are open domains. And I think that we're not the evidence is all that you cannot do the open domains. That's why the chatbots are failing in the ways that they are. I think overall, what happens when you have these templates that you're filling out is you put a huge burden on the person who's interacting with them to adjust to the system. And I've always thought our job should be to get the system to adjust to the person. So I think it is a serious concern, and it actually, for me, branches over into an issue that's come up really internationally. It's getting a lot of press in the United States, which is AI going to take all the jobs away? And I don't know if you have these systems in the Czech Republic, but we have all of these systems where you call in or you're on your computer and you ask for, consumer advice or customer care. And instead of getting a human being, you get a chatbot, basically, which is script-based. And then when the chatbot fails, which it will do unless you have a very standard request, then you eventually get to a person. So what's happened here is we've designed a system that saves the company a lot of money. That's undoubtedly the motivation. But it isn't good for the customer because you don't get the kind of attention you want. You don't get a social interaction, by the way. It's not a very good job because what you get as the person is you get this little snippet. You have no relationship with the person. You have to, you get some context, but maybe not enough. And then you move on to the next one. Whereas if we designed it instead that you would connect to the person and then the machine would help the person, you'd get a much better experience for the customer and also for the worker, and it would be a division of labor that would work. And it's because even in these settings, many people who call in don't just want the straightforward thing. So it's really...
So I may have another question.
Yes.
Well, it's not a question, it's a remark. When many years ago, when the centering theory came into existence, we tried to compare it with with our ideas about information structure and topic focus and so on. And I and some of my colleagues, we did some analysis of texts, of plain texts, and then we thought that it might be nice to try to apply this to a dialogue, not a spoken one, but a written one. So we took a play, a drama, and looked at the possibility how to analyzes in those terms. And then it came about that it's not only what is in the text that is referred to in the dialogue, but what is something in the situation. So it's not only that you say, oh, shut up, and then you return to your dialogue, but you hear some noise and you refer to the noise, which is out of the context if you read it, but it's certainly not out of the context if you see it on the scene. So I think also this kind of situational context plays a role in the dialogue.
It's very important. And now that people are working on gesture recognition and there's much better vision systems, I think it's a very interesting question of how to pull that whole situational context in. It's really important.
More difficult the task.
Oh yes, it's absolutely
not only
because the idea of focus of attention, which is really a visual idea, it's also your visual focus of attention. And if you see something and somebody doesn't, so there's a lot of work to be done.
Okay, so if there are no further questions,
yes, great.
You have shown one example like one Barbie doll. One slide was there about Barbie doll.
About?
Barbie doll. One doll was there.
Oh, the doll, yeah.
Yeah, doll. So I learned about some expert systems where the systems, they can, from their mistakes, they can learn or they can upgrade by themselves. So next time, if same situation arise, maybe they can act better. So is there any possibility, is there like, if the doll, maybe from his mistakes, she can able to learn, and next time she won't repeat those kind of mistakes and it can be better?
Okay, so there's a two-part answer. That doll and the way it was designed, which is to just follow a script, there's no hope. But could one design that kind of interaction where the system would learn from the mistakes? Absolutely. And in fact, the phone personal assistants do that. So by the way, they're recording everything you say, and then they use this in some way. Different companies have different privacy constraints. So all of the existing speech systems that are out there that you talk into, that Apple and Samsung and so, they're all using what you do to figure out when there's a mistake. They're learning from it. Couldn't ask the privacy question, but that's not my area of expertise. So it is, in theory, possible. Whether it would extend to being able to handle the kinds of dialogue behavior that 3-year-olds and 4-year-olds have, I'm not sure. But in theory, so certainly learning would help the situation. But to learn, you have to have a completely different system architecture.
Thank you.